Hi, welcome to our webinar. My name is John Mosteller. I'm the Director of Service Sales here at ColonialWebb. I've had 23 years in the industry, and my focus has been on the financial impact of mechanical, electrical, and plumbing systems in the built environment.
Hi, my name is Ernie Combs. I'm the Director of Business Development for the construction side of our business. I've been in the industry for roughly 18 years. Half of this time I spent working for a local engineering firm before transitioning to the contractor side of our business. I'm a licensed professional engineer in the state of Virginia, and I'm truly driven to be a source of business advantage for our customers. If you look on the right side of your screen, there's a place for questions. Please submit them during this presentation and we'll try to answer all of them before the end.
Thanks, Ernie. So what are our goals for today? You may be managing a large enterprise or maybe a smaller commercial office building. But overall, there are two things we're hoping that we can accomplish. One is to equip you to make the best financial decisions for your organization regarding mechanical, electrical, plumbing systems. Secondly, is to consider how a trusted contracting partner can be a valuable part of that success equation. So you could be a CEO, a CFO, a facility director, or a property manager. But if you're operating with a budget and you're trying to apply funds where you get the most value, this is geared towards you. We may be presenting more questions than we do answers, but to a degree, that's the intent. Your situation is just as unique as your answers are. So we believe if you ask and identify the right questions, you're on the right path to making the best decisions with life cycle costs.
So what do we mean when we say life cycle cost? The three primary components are capital, utility, and operating and maintenance. Beyond the balance sheet, excessive cost could include lost productivity, downtime, and potential regulatory action. Today, we're going to discuss each of these and their interdependence. Finally, we'll explore how different organizations use their contracting partners to manage risk. Similar to automobiles, a building's MEP system has a life cycle of various costs. This life cycle includes, first, capital, 2, utility, and 3, proper maintenance and repair.
Thanks, Ernie. I love the car analogy. You know, when certain conditions exist, we might be better to replace something as opposed to repair it. For example, we take the car that you mentioned, and say it's 10 years old, it's been reliable, and it's got an excess of 200,000 miles on it. You take it to the mechanic and he tells you the suspension's shot and it's going to be $2,000 to replace the suspension. And you consider, that it's been reliable, but, you haven't done anything to the transmission, you haven't done anything to the engine, and you add on to that the tires are worn. So in the end, you decide to replace it rather than throwing $2,000 immediately at the suspension because you decided that didn't really eliminate the risk of continued ownership of that vehicle. Unlike a car, however, an air conditioning system or a mechanical, electrical, plumbing system is designed to be out of mind, quiet, and functioning. And you're not going to sit in it, so it has no aesthetic value. So we only know if it's serving its purpose, and we may not also know whether or not it's efficient because we don't fill it up with fuel the way we do a car, so that part of it is hidden. So really all we know is our process is working and are we comfortable? So how are capital, utility, and operation and maintenance interdependent? Well, let's start with the operation and maintenance side. How well maintained your systems are going to affect how long they last, as well as how much energy they consume. As that car example we referred to, you would expect to have to replace the car earlier, capital, if you never changed the oil or the other fluids, right? The same concept with air conditioning equipment. Statistically speaking, that catastrophic failure that leads you to have to replace it is going to be sooner if we haven't done that operation and maintenance piece. Additionally, when you neglect maintenance, you're going to expect to spend more in terms of energy. Same thing with the car. In an air conditioning system, you could spend 15 to 25% more in energy with condensers that are dirty. And that resulting higher head pressure is going to mean that you're going to be more likely to have a catastrophic compressor failure. So Ernie, what about utility?
Thank you, John. Let's talk about utility. If you're spending too much in utility cost, it may affect 1, how you decide to maintain your systems in the future. For example, maybe a scope change in your maintenance cost $1,000 a year, but it results in a $2,000 annual energy savings. Second, it also affects what equipment you select if you have to replace it. For example, maybe you need to replace a piece of equipment, let's say a boiler. The like-for-like replacement costs $80,000, but the high-efficiency option costs $20,000 more. However, if you could pay that $20,000 back in 2 years, would that make a difference in how you make a decision? Let's also talk about capital. Like the operating and maintenance and utility examples, the specific systems you purchase will directly relate to 1, the required energy to run them, and 2, the required maintenance and repair to keep them running. John?
Now that we've discussed the interdependence of capital, utility, and operation and maintenance, let's ask some questions to identify some potential ways that you can improve. Let's first talk about your in-house staff. What's in their wheelhouse? In other words, what are the skill sets that they have? What kind of tooling is available to them? And maybe most importantly, where is their time best utilized? And are you really satisfied with the mix of in-house versus contracted services? Our customers use us in one of 3 primary functions. First is the capital side for the replacements, renovations, and upgrades. Secondly, they may use contractors for repairs that are outside the wheelhouse of their existing in-house staff. And lastly, they may use us for planned services. There's really no right or wrong answer. It's more about making sure that you're effective with your strategy.
Do you have a good understanding of when you're going to likely need to spend capital funds? For many managers or owners, there may be unqualified capital risk. If you're not a large business or a government agency, you may not have a risk manager. You may have a different person making capital decisions outside of operating and maintenance. If you're not in the HVAC industry, you may not know how long a system should last or have a solid inventory of year of manufacture. Without these, sometimes it's impossible to know exactly where you are in the life cycle. And unlike the vehicles we drive, many, if not most systems, are not visible without accessing the roof or mechanical room. Some things you need to consider are, if you are near or at the end of the life cycle of a system or component, do you have replacement budgets? Do you wait until it fails or replace it proactively? Are there opportunities to upgrade to systems that offer utility payback? What is my long-term versus short-term interest in the facility? Do you own it or lease it? If leased, who has responsibility for capital expenses? Does it suit your needs for the foreseeable future, or are you planning to move?
So we've been considering your specific situation. First, we talked about in-house versus outsourced contracting. Secondly, Ernie talked about the capital side. Next, we're going to talk about the utility side. And for this exercise, we're going to define the utility as the costs associated with electricity, gas, and water. The U.S. Department of Energy says that if you've got a space such as education or commercial office, that up to 60% of the utility spend in those type of buildings are going to be centered around the HVAC, electrical plumbing systems, which are things that are in this perusal. So the questions really are, if you think of your overall energy spend, how efficient are we right now? Is my maintenance affecting my utility spend? If I've got a control system, is it optimized? Am I on the right rate structure? There could be dozens of rates available to a commercial space in the electrical world. What are my peers spending? And lastly, just that overarching question is, can we do better?
So no one wants to over-maintain their system, but what's the right balance? John, isn't maintenance just changing filters?
Well, Ernie, filters is the part that happens the most frequently, but HVAC systems, at least most of them, require an inspection from a qualified or trained technician 1 time a year, maybe a little bit more. Let's take the boiler as an example that you brought up earlier. That boiler is going to need igniters probably. It's going to have safeties definitely. It may need combustion analysis, and it's going to have a heat exchanger that needs to be inspected periodically. So I think the question really is more towards what should I handle with my in-house staff? Do I have the qualified personnel on staff? Do I have the tools to do it? And then what should I use for outside contracting? And then what are the implications of the reactive versus the planned strategy? And do I know what the manufacturer recommends? As we start to wrap up this section about identifying your situation, we'd like to name 4 things that we see quite frequently in our industry. And I'm going to start with the first. And I call it decision-making silos, where you may have one individual making decision on capital and a totally different individual making decision on operation and maintenance. And if they're not collaborating enough, then you could be in for that surprise when maybe you've done a great job on the operation and maintenance, but then you have that unexpected capital expense that never made it into the budget.
Second is going to be managing capital reactively and to the lowest bid. Results can include reactive capital spend that is typically higher. Failures can occur during the peak of heating and cooling seasons when systems are under the most stress. This results in higher demand on contractor labor and higher demand on equipment suppliers. To me, the biggest issue, though, is the lost opportunity to plan and optimize.
The third thing that we'd like to mention is managing to lowest first cost for planned services. And don't get me wrong, this may be the best strategy, especially if you have a short-term interest in a property, maybe someone else is responsible for capital, or maybe you're under the warranty condition. But overall, we find operation and maintenance costs end up being higher because the minor problems in a reactive strategy will end up costing you more for that catastrophic failure that occurs because you didn't know about it.
And fourth, lastly, beyond the balance sheet, excessive costs can include downtime, lost productivity, and potential regulatory actions. As an example, in the past year, we've seen how important it is to maintain good indoor air quality, but that's the subject of a future webinar.
So do you have the information you need to manage to life cycle costs effectively? For many organizations, I feel it's a matter of capability and bandwidth. Some of our customers may have a risk manager. They may be an institutional level customer that can afford such a great position to look at the overall picture. But many of our customers have people that are capable of doing it, but they have bandwidth. They have a main job that they're doing, and this is just part of it. And so effectively, it's not managed as well as it could be, not because they're bad people, but because they don't have the bandwidth to dedicate to it. So these questions are just put out there for you to really consider. Are you managing to all 3 components, capital, utility, and operation and maintenance, as effectively as you can be? Because if you're managing just 1 or 2 of these well, but you're missing on a third, you're probably paying too much. So how can a contractor like ColonialWebb help? Contractors at both service and install have got continuous application experience. We can assess risks based off of the age and the conditions. We can make recommendations based off of our vast experience. We got many diagnostic tools, so the more complex the situation, the more likely that you're going to need a contractor. And we understand the system designs and what typical reliability really means for your system.
We also know the trade-offs between efficiency, reliability, and life expectancy. We can help with budgeting because of our historical bid databases. We know equipment lead times and project durations. We also can assess site conditions that affect productivity and cost.
In terms of utility, ColonialWebb can provide solutions to energy optimization, including things like benchmarking, looking at your building compared to your peers, energy dashboards, real-time consumption of energy, monitoring and optimization of an existing automation system, and then commissioning or retro-commissioning for an existing building.
In terms of capital, we can help you with the following solutions: asset evaluations, due diligence reports, design build or design assist projects, or direct replacements.
Finally, maintenance and repair. We can complement an existing staff, or we could provide a turnkey solution. Planned services, full-time equivalents, major repairs or refurbishments, and minor repairs. We're going to take a 2-minute break. We'll be back for a Q&A session afterward. A short video will be playing while we're away, and there will be a place on the right-hand side of your screen to type questions. So we'll see you in just a couple minutes.
What is ColonialWebb Care 365? Plain and simple, it is peace of mind for your business. Because your HVAC systems are required 365 days per year, regular planned maintenance and care will keep your assets performing reliably and efficiently. Operations and maintenance is one of the three primary components of life cycle costs. The first costs, operations and maintenance expenses, are a visible factor. Your system's condition directly affects the other two components, capital spend and energy consumption. Opportunity may exist for improving your utility spend and your indoor air quality. However, risks may exist for capital expenses. Do you know your inventory and capacity of systems? How old your systems are? What the expected life cycle of those systems should be? Your needs are unique to your situation. What is outsourced? What is handled with in-house staff? What are your objectives? How many assets are in your inventory? We'll provide customized options so you can make the best decision for your organization. The outcome of having ColonialWebb Care 365 are systems running as designed, lower lifecycle costs, and better risk management. Protecting your critical assets with professional ColonialWebb Care will help you maximize the life cycle of your investments. Visit ColonialWebb.com to learn more about our building service offerings.
Welcome back. We appreciate you staying with us. During this podcast or this broadcast, we have talked about the components of life cycle, capital, utility, and operation and maintenance. And we asked a lot of questions of you. Now there's a chance for you to ask us some questions, and we'll do our best to answer them. As a reminder, there is a place on the right-hand side of your screen to put the questions in. But in the meantime, we did get a few questions from our LinkedIn channel, and we will start with those. So Ernie, the first question is, well, I actually see two questions as probably the same thing. It says, what is an asset evaluation, and how would I go about quantifying my capital vulnerability? How would you answer that?
That's a really good question. So it starts off with developing a thorough inventory of exactly what equipment you have to understand your risk. It's the type of equipment. What does it service? The age. Trying to build an understanding of what your 10-year expenditures need to be, 5-year, 2-year, and what your immediate risk are. And if we think about the capacities, for example, and the quantities of those, what we often find is when we put together an asset evaluation for a customer, we will see that there's some surprises. Maybe they didn't realize that there were so many components in a system. So the order of magnitude sometimes can be a surprise for customers. Or, oftentimes we'll see buildings that are built over phases. So we'll see some equipment that's new, some that's middle-aged, some that's really old. And so it's not homogeneous in terms of where the risk is. It doesn't necessarily everything need to be replaced at the same time. So we're trying to assess where that risk is and when that capital budget should be planned for. Absolutely, well said. Also, we can see trends in fading technologies that are no longer effective or not as energy efficient, and we can plan for something better.
Okay. Next question we have is, what methods do you use to benchmark buildings to determine if utility spend is too high?
Also a good question. Typically what we use right now are Energy Star and CBEX, and we look at dollar per square foot to see if, based on your building type, whether you're spending more in energy cost or less.
Okay. And how long should my HVAC system last? How would you answer that?
That's definitely a unique question. I feel like definitely a good question, but it really depends on the type of system you have and how you're operating it. ASHRAE has some good guidelines on how long equipment should last, but it really is based on the type and how you're operating it.
Are there tools an individual can use to determine return on investment when looking at utility versus capital spend?
I would say it's really the best way to answer this one is each individual system is different, and it would be something that you could give us a call about, and we could answer based on historical data that we have.
Yeah, I'm not sure if the question may be, what is the metric that your organization uses to? Is it net present value, for example? What do the financial people in your organization use to justify a project? A lot of times what we see is competing capital. In other words, there's always more things, the alligators that are nipping at you than you can beat away, right? So you've got to prioritize. So a lot of times when we look at return on investment, is which projects actually rise to the top in terms of which ones give me the most payback. So if we understand how your organization makes decisions in terms of what the financial metrics are, then we could help you with that, because there's a number of ways to be just like a simple payback, or it could be something a little more complicated.
Well said.
If I need to replace major pieces of my HVAC system, how do I determine a budget?
So there's many things that go into the replacement cost of a piece of equipment. It's not just the equipment cost alone. It's hoisting and rigging. It's building automation. It's testing and balance, the labor, and also downtime. How long can you have it down for?
And as I think about that question, major pieces of my system, how to determine a budget, that asset evaluation is really a good tool for that. If you contact your ColonialWebb representative, they have tools through, we have data analysis from past budgeting and past projects that we've done that can help with kind of an easy button, because we've probably done something similar in the past. So we have a database that we might be able to pull from. Okay. There's another question. What is the basis for determining an asset's life expectancy?
So I would say, as we mentioned earlier, ASHRAE has a really good guide for that, but it's also, I would say, our past service records. We understand that, hey, if ASHRAE says a pump should last for 20 years, but we're seeing that type of pump typically last for 22 years, that's the information we're providing to our customers.
Right. I think that's an important part, because ASHRAE can give you the guideline. It could say ductwork lasts typically 30 years, but if it's been in a really poor environment and it's really had harsh conditions, it may not make it to that. Conversely, I was looking at an opportunity with an organization yesterday, actually, and it was a system that was 50 years old, and it has well exceeded life expectancy by ASHRAE standards, but it didn't get used a lot. So we do see extremes in that. So if we look at the application of that piece of equipment and the condition, it can help us. Here's another one. You said it was less expensive to replace proactively than upon failure. Can you help me understand that?
So most systems don't have, I would say, redundant or backup heating or cooling systems. So if you don't plan for it and you're not able to move people out, you might have to have rental equipment. You might have to pay for overtime for labor to get things installed. You might have to pay for expedited shipping to get equipment there faster. So there's several components that go into, I guess, a reactive equipment replacement versus proactive. Also, it's not just, sorry to cut you off. It also goes into a planned replacement is always better, because you can look and see if there's a much more energy efficient option. Are you using the building the same as you were in the past? Several things.
And another thing I thought of, Ernie, as you were describing that, is we oftentimes find if we're replacing it reactively, do you even have a choice in terms of equipment manufacturers? If we're planning it, we can potentially look at various original equipment manufacturers and see, hey, what's available? What's the best solution? Is there a better fit here? So if we can do that planned as opposed to reactively, then we may not even have a choice, because again, as we talked about, most times things are going to break in under the worst stress. And that's actually the last question we've got here is, why do systems fail on the hottest or the coldest days?
And that the simple answer is the systems are under the most stress during those times.
Pressures are higher in the summertime on refrigerant side. So yeah, those sort of things do factor in and cause the failures to occur typically. It's basically just like your own health, right? If you're going to run a marathon and it's 95 degrees out versus running a marathon when it's 40 degrees out, your body's going to behave differently, and it's going to be under different pressures. So, okay. Ernie, that looks like all the questions we've got for today. As we close this out, we want to thank everyone for investing time with us today. There will be future webinars. I think our next one is going to be one that will spark some interest based on where we've been in the last year plus, and that's on indoor air quality. I would like to add a personal note. I'd like to thank Wendy Pike and Connor Burke for all of their efforts in producing this webinar. We couldn't have done this without you. You've done a great job. And finally, if you think of questions after this is over, contact your local ColonialWebb representative, or you can reach out to myself or Ernie directly, and we'll be happy to assist you.
This has been a lot of fun. Thank you so much.
Thanks.